let's comment this. And to save the change, whenever you want to save the change that you are making, do it in the same variable so that it will be updated. So in the B variable, I want to rename MPG to uppercase name. For that, I'm using piping operator here. So let's execute it and see the change. So you can see MPG was earlier in lowercase. I have converted into uppercase. Similarly, if you want multiple columns to be renamed, first, so you have to give the new name equal to old name, and then you can give comma, then the other variable name. So let's execute it and check the variable. So you see we have updated all the column names. Next function is summarize. So summarize function, it helps us to calculate the statistical functions, statistical summaries from our data set. So here we are using DF data set using piping operator, then giving the formula, that is the summarize function. Within the bracket, we are first giving the name of the column that we want, that is displacement, and the function we are using for that is mean displacement. Let's do a simple one first using the variable or the data set that we are using, giving piping operator, then summarize. Then what we want is mean MPG. So suppose I am saying MPG, MPG, which means mean of MPG. Then giving the function name. Let's see if we get any value here. So you can see there is the mean value of MPG, that is 20.09. So it returns one value, that is the column mean of MPG. Next, we are using summarize function in the dataset DF, and I am saying in the column, give the column name as displacement, DISP, and in that I want mean displacement, and for HP I mean mean horsepower. So you see there were two variables, displacement and horsepower, two columns we have taken, and the value has been printed. So 230.72 is the mean displacement value, and 146.68 is the mean horsepower value. Similarly, what we can do is we can get the count also. So if you want to give count, another column for count, for that the function we use is n and brackets. It will give you the total counts for those values that we have grouped. So now we are using group by command along with summarize. So let's take the df here. So my data frame is df. I am grouping my data frame using cylinder variable. Then so there are three types of cylinders. So there will be three groups. Then summarization will be done, wherein we want mean displacement and total number of count for that row and for that set. Let's see what is the output. So there are three types of cylinders, as I told you, 4, 6 and 8. Then each of the values, mean values for each cylinder type. So for 4 cylinder type, the mean displacement is 105, and there are 11 cars where 4 cylinders are there. Similarly, 183 is the mean value for 6 cylinders having for 7 cars. Then 14 cars having 8 cylinders, their mean displacement is 353. So you see how simple it is to manipulate your data and get an accurate output using dplyr packages, package functions. Then there is AM. So now we are grouping our data frame using AM. So there are two types of AM, that is transmission. So there is automatic and manual, and we will be summarizing our data, calculating mean MPG for each of the transmission type and getting total number of cars. So there are two transmission, as I told you, 0 and 1, that is manual and automatic. So mean MPG for the automatic is 17.1, and for manual it is 24.4, and 19 are the and 13 are the total of the cars for each of the transmission. Next function is filter function. Filter, what does it help with? It helps to filter out or filter out the rows given the condition with the function. So here let's execute the first command, which is the filter for cylinders equal to 6. So what we want is out of our data set. So we are taking DF as our data set. We want all the rows wherein we want all the data wherein cylinder is equal to 6. So let's execute this command and see what is the output. So there is 7 rows that we got in our output, wherein we have selected all the data wherein cylinders is equal to 6. So we have grouped the data with 6 cylinders. Next, using piping function. So I am using my data frame, then giving the command filter and a condition that is carbonators greater than 4. So all the data, all the rows wherein the carbonator value is greater than 4 will be filtered. So there is only 2 cars wherein the carbonators are greater than 4. You can see there are 6 and 8 number of carbonators in these 2 records. The next is wherein we are taking MPG that is greater than mean MPG. So it will automatically calculate mean MPG and will return all the rows that are greater wherein the value of MPG is greater than the mean of whole MPG column. So there are 14 cars where the value of MPG is greater than mean of the whole column of MPG. Next is using our data frame and the piping operator. We want this function to be applied to this data frame. So filter all the data wherein the cylinder is greater than 2 and carbonators less than 4. Let's see what is the output. Okay, so there is no record related to this data where there is no car, where there is no common number of cars here. So what we'll do is we'll just take cylinder and let's say displacement. So what is the range of, let's check the range of displacement first. So it is from 71 to 472. So what we can take is greater than, suppose 100. So what we are taking is cylinder equal to 4 and displacement greater than 90. So let's see what is the output. So there are 7 records wherein the number of cylinders are 4 and displacement is greater than 90. Next, we are taking a new data set, that is the air quality. Let's see what we are going to filter out here. So we are filtering all the data wherein temperature is greater than 70 and month is greater than 5. So if you want to see what is air quality here, you can check the first 6 rows. So the name of the data set is air quality. So what we want is temperature greater than 70 and month greater than 5. If you want to check the structure of this data set, you can also check that so that you know what all are there. So there is different days, then different months, and temperature, wind, solar, and ozone. So let's execute this command. So you can see there is 113 records where temperature is greater than 70 and month is greater than 5. So month is 5, 6, 7, 8 and 9. So all the month is greater than 5. If you want to check the structure that we already have checked. So there are 153 records and 6 variables. Now let's go ahead to the mutate function. It is a very easy and very effective function. How can we use that? So it helps us to add a new variable to data. How will we adding a new data is we are using air quality here. So you can see the temperature. The temperature is in Fahrenheit form, degree Fahrenheit. What we will be doing is we will be adding a column for Celsius degree values. So to convert the Fahrenheit into Celsius, the formula is 32 degree Fahrenheit minus 32 into 5 by 9. So it gives you 0 degree Celsius. So we will be taking the temperature column from the air quality data set and we will be putting this function into that. So to use mutate function, what we'll do is, so first we are taking the name of the data set. Then I am giving a name to the column, that is temperature in Celsius. So in this variable, what formula I want is all the values of temperature minus 32 into 5 divided by 9. So let's execute this command and let's see what will happen, because there are many rows. So let's see the first 6 rows to get a easy output. So you see we have added one more column here, which so we've mutated our data from the existing one to a new column. So all suppose the first value of temperature here is 67. So it subtracted 32 from that and multiplied 5 by 9 to get the value of degree in Celsius values. So this is how mutate function is used. Last is arrange function. So arrange functions helps to change the order of rows. We can sort the data in ascending or in descending order. So we are using our data set DF here, and we will be arranging our data set according to cylinders in the decreasing value. So to set the order into decreasing, the formula we use inside arrange is DESC. It will specify the order into descending one. So how do you know that we have the orders in descending? So you can see there were 3 types of cylinder, 8, 6 and 4. So all the data, the first data is of cylinder number 8. The number of cylinders are 8. Then there is data related to all the cars having cylinders equal to 6, then with 4. So it has sorted the data in a way wherein the value of cylinder is greater than the others. Similarly, what you can do is you can group by and then arrange. So in our next function, what we are doing is we are taking the data frame, grouping it by cylinders, then giving the arrange formula wherein we are arranging according to descending order of MPG. So the groups will be formed with the help of cylinder. So there will be 3 groups. Then the arrangement will be in descending MPG values. So you see what happened is the largest value of MPG was 33.9 and groups has been made. So the first all the rows will be including and the numbers as 4 in the cylinder. Then there will be 6 and the greatest value of MPG will be there. Similarly, there is one more way you can add, you can arrange the values. So the function I'm using here, arrange. The data set is DF. Then I am grouping it by cylinders and giving displacement as decreasing order. Let's execute it. So there are 32 rows as we know. So what happened is we have grouped it according to the cylinders, 4 first, 6 then, and then 8. Then you can see we have said the displacement should be in decreasing order. So what happened is, so you see the first group is 4 of 4 cylinders, and this is the displacement value here. This is the displacement value. Next column is of displacement, wherein the first value is the greatest value, and the last record in 4 cylinders, number of cylinders is least. Similarly, next group started with 6 with the greatest value of displacement 258. So what is happening is the data is updating according to 2 variables, but the whole of the row is shifting. It is not like only the values of displacement or cylinders are changing. Whole of the row is moving up or down according to the sortment that we are doing. Next, we are arranging our data set according to weights, wherein we will be arranging according to decreasing weights. So the 5.424 is the highest value of the weight and 1.513 is the lowest value. Next, the last one that I'm taking here is arranging function for air quality data set, wherein I'm saying a descending order of month and increasing order of days. If you're not putting any descending value in before any variable, it will be ordered in increasing way, and the DESC one will be in decreasing way. So let's see what will happen. So 153 records. Let's go up. And you can see I wanted months in descending order. So the highest month is 9 here. You can see it is 9th till here. 9th month, 30 records are of 9 months, and the days are in ascending order. So 1, 2, 3, 4, 5, they are in ascending order and grouped according to the number of month. Then ninth, then there was 8th, then 7th, then 6th, then 5th. But you can see days are in ascending order. So this is all about data manipulation. So we covered filter, then there is mutate, then select, summarize and arrange. All these can be used along with the group by function. Filter, it return all the rows that satisfies the condition. It is generally used with relational or logical operators, and the function used is filter. Then there is mutate, which helps us to add new variable to our database, to our data set. The function used is mutate. Then there is select function, which helps to select the columns based on conditions. Then there is summarize, which helps to summarize multiple values into single value, grouping them according to categorical or factorial variables first. Then there is arrange, to order our rows by one or more variables so that we can sort it into ascending or descending order.